when I moved here, I wanted to start working on projects that really mattered to the people who live in the community, and managing the dunes and the communities that sit right on the dunes like Pacific City or Cannon Beach, Bayshore, is a challenge for Oregon state managers.
That's Meagan Wengrove, an assistant professor of coastal and ocean engineering at Oregon State. Today we're going to hear from her about a collaborative project to study dune erosion that she co-leads with investigators at 8 institutions around the world. In a massive experiment, the team dumped 56 truckloads of sand in a lab at Oregon State. Of course, you can't do that in just any lab. This is the largest nearshore experimental facility in the nation at an academic institution called O.H. Hinsdale Wave Research Laboratory. I'm your host, Chris Palmer. In this episode of Engineering Out Loud, we'll hear about Meagan and the dune experiments she performed at the Wave Lab and what they might mean for coastal communities in Oregon and other parts of the world. From the College of Engineering at Oregon State University, this is Engineering Out Loud.
I really enjoyed how complicated the coast is, with waves and currents mixing together, moving sand, vegetation that might be there, and hearing that about 50% of the world population lives by the coast, and so it's a really important buffer zone between the land and the ocean and important for people's everyday lives. So that's the path I went down.
That path took Meagan to pursue advanced degrees in water resources engineering and coastal engineering. It also took her to the Netherlands on a Fulbright scholarship.
Although I learned a lot with my research, I also learned a lot just being there with the culture that they have surrounding water and water resources. And the people, for the most part, really respect the power of the sea, and they know how damaging the ocean can be to their lives. 2/3 of the country is below sea level, so the political and economic investment that they make in water resources is substantial. So I think that was a big eye-opener for me to see how they manage their water infrastructure.
After wrapping up her graduate work in 2018, Meagan brought those lessons and her passion for water to Oregon State.
Oregon State has one of the best coastal engineering programs in the world and one of the best oceanography programs in the world. So it was really great combination of the two things that I study and wanted to be involved with. I really enjoy working in the Hinsdale Wave Lab. I think it's a super unique facility that OSU offers, and there's a great staff there that helps your research aspirations come true in that facility. So I think having this large-scale dune erosion project there has been really exciting.
Among Meagan's aspirations has been studying one of Oregon's most notable nature-based features, the towering dunes that dot Oregon's coast, including the largest expanse of coastal dunes in North America, stretching 40 miles from Coos Bay to Florence.
A natural or nature-based feature is a dune or a marsh, a mangrove system. It could be a cobble beach, anything that Mother Nature has originally created that we can leverage for our own benefit too. And so in Oregon, dunes is one of the biggest.
In fact, Frank Herbert's masterpiece, Dune, was inspired by the massive dunes on Oregon's coast. Early in her tenure at Oregon State, Meagan met with land use managers for communities that sit adjacent to coastal dunes. Their conversations landed on what happens to dunes during storm surges like you get in El Niño events on the West Coast and hurricanes on the East Coast.
So during a hurricane, the dunes could behave a few different ways. One could be the water levels get just high enough that you start to get surge erosion. Surge is the extra water that's piled up on the beach from the wind from the hurricane blowing water on shore, basically. And when the water level gets high enough, then the waves have the ability to impact the dune and start eroding the sand away. This could happen on a dune or a coastal cliff. When that happens, the community that's behind those dunes is vulnerable to having that dune eroded away enough that if their house is sitting on top of the dune, then it might fall in the water. Or if there's a road that's going on top of the dune, which we do have in different places around the U.S., that road starts cracking, and it's a lot of money to repair those coastal infrastructure.
Also, if the water gets high enough, it can run over the top of dunes and into adjacent communities, with devastating consequences.
So that happened in Hurricanes Sandy and Katrina. Whole communities were inundated, so there's kind of a scale of damaged states.
Often, coastal managers attempt to prevent erosion in vulnerable spots by building seawalls.
While those solutions do tend to trap sediment or stop erosion at that particular location, they have edge effects or they'll create more intense erosion problems adjacent to those properties. So they're not the best solution.
Another common tactic is nourishing beaches and dunes. That's a fancy way of saying adding more sand.
So sucking it up offshore somewhere with a big dredge ship and then spitting it back out on the beach. So that's one pathway that usually needs to be done every 4 or 5 years. Another option is that managers will go in and try to not only put sand on the beach, but then replant the dunes with vegetation in hopes that the wind will blow sand from the beach, from the other part of the nourished beach, into the dunes. That sand will get trapped by the vegetation and will make the dunes wider and or taller.
That brings us to Meagan's experiment in the Wave Lab's wave flume, a long, narrow tank of water where waves are mechanically generated on one end and crash at the other end.
So the process for this experiment was initially we had to build the dune in the flume. The flume is 104 meters long, 4 meters deep, and 3 meters wide. So it's a big facility. We scaled the dune to a 1 to 2.5 scale, so it would fit into the flume. And we trucked in 56 dump trucks of sand from the Oregon coast to fill this flume. That was quite the process.
They then constructed the dune, buried sensors to monitor pressure, moisture, and sediment velocity and morphology, planted the vegetation, and built a greenhouse on top of the dune to encourage the plants to take root.
After 6 months, we took the greenhouse down. The plants were fairly well established, but nothing like a dune that's been in place for 10 years. And then we ran waves over that dune. Once we were done with the experiment for the vegetated dune, we rebuilt the same profile and did a bare dune case with no vegetation, just bare sediment. And then when that component was over, we did a biocemented dune where we sprayed and injected this bacteria mixture on the dune and fed it with urea so that the bacteria would actually cement the sand together like sandstone.
The first thing that Meagan and her colleagues looked at was mechanisms that create a dune scarp, the steep step of a dune face that forms when a big storm carves away a bit of sand from the front of a dune. Then the next time a storm blows through, the scarp gets wet, making it heavier than the dry sand behind it. That causes the sand to slump off, exposing more dry sand to storm surge and even more slumping. Soon the scarping progresses landward, leaving homes and roads more vulnerable to future storms.
So what we don't know, or we didn't know, was how do those scarps form initially? When do they form? Where will they form? What are the characteristics of the beach face and the sediment that would cause a beach to be vulnerable to scarping in the first place? So how could we quantify a community's or a dune's resilience to scarping?
That's where the instruments they buried in the dunes come into play.
With those instruments, we were able to identify that there's actually a lot of liquefaction events, which is when all the sediment particles momentarily are completely suspended by water. The pressure gets so high that the sediments begin to become unstable, and when there's a bunch of swash events, they infiltrate through the beach, and the internal pressure in the dune gets high enough that during a subsequent swash event, the water can no longer infiltrate through the sediment, and when the wave rushes back down the beach, the water actually exfiltrates through the beach.
That means the water runs up and out of the beach like a fountain, forming a scarp. Knowing how this works can help predict which beaches and dunes are at risk of erosion. And as far as whether vegetation helped protect the dune from erosion,
we expected the bare dune to scarp sooner than the vegetated dune. That was our hypothesis, because there was no roots of the vegetation holding the sediment in place. But what we found for this newly planted dune was that the stems of the vegetation created little pockets of instability where there's like micro scour around the stems themselves, and those vegetation stems made it easier for the dune to scarp, which was counterintuitive. We really thought that the vegetation would hold the sediment in place for longer. But we think that likely even on more established dunes, the stems still create these little pockets for scour that could make the dune scarp sooner than a bare dune.
In contrast, in dunes with long-established vegetation, Meagan believes the root structure is so well developed that even if the dune scarps earlier, the roots are more likely to hold the sediment in place, meaning the dune won't scarp back as far. That's something she plans to investigate in the future. As for the biocemented dune, the team found it held together longer than both the vegetated and bare dunes. But they also discovered that the outer shell of the biocemented layer could be undercut by the waves, eventually resulting in that layer collapsing. Meagan and her team are now working on disseminating their findings to coastal managers in Oregon.
So I guess our biggest coastal manager we've been working with is the U.S. Army Corps of Engineers. And right now we're working with them on a project to start to implement some of these processes, especially the internal hydraulics, so how the water's moving through the dune into the numerical models that they use to predict coastal vulnerability for the communities that they manage. That's something that's not currently in any of the coastal engineering models, and something that's very important to sediment transport. So it's an exciting path forward.
They are also planning field research to better understand the role that well-established vegetation plays in preventing erosion of coastal dunes. In addition, they are doing field work at Nehalem Bay State Park, about 3 hours northwest of Corvallis, to investigate the opposite of dune erosion, which would be dune growth. They are working to understand the role that invasive and native Oregon dune plants play in the growth and evolution of coastal dunes.
In Oregon, we have a pretty big sand supply, and the communities that are not having erosion problems often have a pretty significant amount of sand piling up on their beaches, and when there's a big wind event, the sand is picked up and blown through the dunes and piled on top of people's houses, like to the roofs of people's houses on the coast. And so they have to go out with bulldozers and excavate their house out after big storms.
Communities that have to deal with this excess sand are allowed to grade the dunes down, but they're also required to replant the dunes with vegetation to stabilize the sand. This practice causes a significant amount of contention. Some folks want to see the ocean, while others want to keep Oregon wild and not touch the dunes. But where the dunes are graded, the guidelines say to replant them with European beach grass.
That is an invasive grass to Oregon, and it's actually squeezed out a lot of Oregon native plants as well as the West Coast snowy plover bird.
Meagan and her team are partnering with the state of Oregon to test two things. First, they'll test if native plants can be restored to the Oregon coast. This would increase ecological diversity of the dunes and allow them to grow naturally lower in elevation, which could benefit communities desiring coastal views without grading the dunes down, while keeping Oregon wild. State officials may be convinced to change their regulations, which could help preserve the habitat of the snowy plover and other native species. Second, the two invasive grass species in Oregon have hybridized, resulting in a breed that grows tall and traps sand especially well. If the hybrid grass takes over, it could change the full landscape of the Oregon coast. This grass was discovered by Oregon State professor Sally Hacker. She, along with Meagan and their team, are investigating how the hybrid grass changes the shape of a dune. This knowledge would be important to coastal managers in Oregon. Big projects like this require the effort of a lot of different people with specialties ranging from coastal hydrodynamics and sediment transport to ecology and computer modeling. Two other engineering faculty joined Meagan on the project. Dan Cox, professor of coastal and ocean engineering, who worked on coastal resiliency estimates, and Matt Evans, professor of geotechnical engineering, who worked on dune biocementation processes. The team also included researchers from other colleges at OSU, including previously mentioned professor of coastal ecology Sally Hacker and professor of geomorphology Peter Ruggiero, who works on the ecomorphodynamics of coastal dunes in Oregon.
That project was the collaboration with people from 8 different universities. We had close to 30 faculty and students working on the project, so it was a really big effort, lots of energy that went into it. So I by no means did that project on my own. It was a big collaborative work.
Students at Oregon State benefit from research projects like this by having the opportunity to experience research directly, rather than just reading about it.
We had 15 students working on the project in various ways. We had graduate students from 5 different universities, and then we had undergraduates from each of those universities as well. The students really, they built the dune, they set up the instrumentation, they took the measurements, they processed the data, and wrote the papers, and so they were integrally involved in the entire process from start to end, and it's been really fun to see that community. They were a community together here in Oregon that summer, and they still check in with each other and are excited about each other's findings and research. So, yeah, I don't think the project would have happened without the students.
One of those students was Haley Bond, who we had a chance to talk with about her contributions and experience with the project. That's up next. This part of the episode was produced by me, Chris Palmer, with lots of help from Will Habner and the whole Engineering Out Loud podcast team.
This is Rachel Robertson, executive producer of Engineering Out Loud. What you're about to hear is a short segment produced by Alec Bovey, who is a second-year engineering student here at Oregon State. I first got to know Alec when he emailed me out of the blue. Alec, can you tell about what motivated you to do that?
Well, I just really like the podcast, and as a longtime listener, I wanted to see if there was a way I could be involved.
Cool. And so you have.
Yep, and I've come to some of your interviews, read over scripts, and even gave comments.
Which has been really helpful to have your insights. And most recently, you came up with this idea to have a short segment at the end. Can you explain about your idea?
Yeah, I just thought it'd be interesting to have part of the episode be focused on a student.
And I thought you would be the perfect person to do that. So this is your first assignment. Who did you talk to?
I interviewed Haley Bond, who worked on the NSF Dune project as a master's student. After getting a degree, she worked for the Department of Land Conservation and Development as a Sea Grant Coastal Fellow. And she'll be back at Oregon State in the spring to start work on her PhD. I really enjoyed talking to her because I got a better idea of what it would be like to be a graduate student. Take a listen.
I helped get the lab all set up in my first year, and then the experiment happened during the summer after my first year. I got to help with all of the instrument deployment and setup, and then by the end of the lab experiment, I was running the wave machine, which was probably the coolest thing I did at OSU. Afterwards, I specifically analyzed the pressure sensor, moisture sensor, and LiDAR data to try and figure out something about how dune scarps form. So like when there's a lot of erosion and there ends up being like a flat face on the front of the dune, trying to figure out when and where those are likely to form.
And how did you actually get involved in this research in the first place? Like what made you interested in it?
So I was interested in coastal engineering for grad school, and I applied only to OSU, which is kind of unusual. So I was really lucky to work with Dr. Meagan Wengrove, and she already had this project funded. So I kind of got swooped up into this project, and it fit with what I wanted to do, which was coastal engineering that was like somewhere in between being fully academic and being applied.
Haley found coastal engineering in a book of majors and decided that was going to be her focus in her undergrad, and eventually when getting her graduate degree.
It's civil engineering, but with a bit more of a dynamic. The coast is a more dynamic environment than you find with typical civil engineering projects.
When Haley started on the dune erosion project, she was only one of few people working on it. But once the experiment started, there were students from Texas and Delaware to Puerto Rico and Korea.
So it was a really big, interesting group of people that was kind of constantly changing throughout the whole summer. And so it was really, really fun and interesting to meet all of those other people. I really got to see the project from beginning to end. I learned a lot about all of the instrumentation, like setting up all of the instruments, which I had no idea about. It was funny at the beginning of the project when all of the professors were saying, okay, do this and this and this. I had no idea what anybody was talking about. But then by the end of the experiment, I was able to like have a conversation about all of those things because they all made sense. So it was fun to kind of start to feel like really confident in there by the end.
Are there other tips that you can maybe give other undergraduates or graduate researchers?
I think the biggest advice that I would have would be to talk to professors because they're not that scary. And especially in the coastal department, all of the professors are really friendly. And I was able to lean on a lot of different people for help and talk to older graduate students when I needed help later in the project, getting help with data processing and understanding what was going on. It was nice to have a friendly relationship with the people who really knew what they were talking about. And it's also a good way to get involved in something you're interested in is just to go to the person who's doing it and ask questions because they'll always be happy to talk about it.
What really impressed me when interviewing Haley is that she didn't really start out as an expert running the wave lab or analyzing data. However, it's inspiring to see that through immersing herself into the project and trying to get the most out of the research, she's now able to bring her own insights into the coastal engineering world.
In the coastal world, we're not talking anymore about whether or not climate change and sea level rise are going to be affecting anything. We're studying how they are already affecting these places. So yes, definitely. I think sea level rise is just going to continue exacerbating erosion. And so research like this is important in trying to figure out what kinds of effects that will have on, for example, in my case, the dunes that are protecting communities that are behind them.
This part of the episode was produced by me, Alec Bovey, with special help from Will Havner, Rachel Robertson, and the rest of the Engineering Out Loud team. Our intro music is the Ether Bunny by Eyes Closed Audio on SoundCloud, used with permission of a Creative Commons Attribution license. The music and effects in this episode were also used with appropriate licenses. For more information, visit engineeringoutloud.oregonstate.edu.